Section 5 of the Concept of Nature by Alfred Whitehead. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Space and Motion. The topic for this lecture is a continuation of the task of explaining the construction of spaces as abstracts from the facts of nature. It was noted at the close of the previous lecture that the question of congruence had not been considered, nor had the construction of a timeless space which should correlate the successive momentary spaces of a given time system. Furthermore, it was also noted that there were many spatial abstractive elements which we had not yet defined. We will first consider the definition of some of these abstractive elements, namely the definitions of solids, of areas, and of routes. By a route I mean a linear segment, whether straight or curved. The exposition of these definitions and the preliminary explanations necessary will, I hope, serve as a general explanation of the function of event particles in the analysis of nature. We note that event particles have position in respect to each other. In the last lecture I explained that position was quality gained by a spatial element in virtue of the intersecting moments which covered it. Thus each event particle has position in this sense. The simplest mode of expressing the position in nature of an event particle is by first fixing on any definite time system. Call it α. There will be one moment of the temporal series of α which covers the given event particle. Thus the position of the event particle in the temporal series α is defined by this moment, which we will call m. The position of the particle in the space of m is then fixed in the ordinary way by three levels which intersect in it, and in it only. This procedure of fixing the position of the event particle shows that the aggregate of event particles forms a four-dimensional manifold. A finite event occupies a limited chunk of this manifold in a sense which I now proceed to explain. Let E be any given event. The manifold of event particles falls into three sets in reference to E. Each event particle is a group of equal abstractive sets, and each abstractive set towards its small end is composed of smaller and smaller finite events. When we select from these finite events which enter into the makeup of a given event particle those which are small enough, one of three cases must occur. Either 1. All of these small events are entirely separate from the given event E, or 2. All of these small events are parts of the event E, or 3. All of these small events overlap the event E but are not parts of it. In the first case, the event particle will be said to lie outside the event E. In the second case, the event particle will be said to lie inside the event E. And in the third case, the event particle will be said to be a boundary particle of the event E. Thus there are three sets of particles, namely the set of those which lie outside the event E, the set of those which lie inside the event E, and the boundary of the event E, which is the set of the boundary particles of E. Since an event is four-dimensional, the boundary of an event is a three-dimensional manifold. For a finite event there is a continuity of boundary. For a duration the boundary consists of those event particles which are covered by either of the two bounding moments. Thus the boundary of a duration consists of two momentary three-dimensional spaces. An event will be said to occupy the aggregate of event particles which lie within it. Two events which have junction in the same sense in which junction was described in my last lecture, and yet are separated so that neither event either overlaps or is part of the other event, are said to be adjoined. This relation of adjunction issues in a peculiar relation between the boundaries of the two events. The two boundaries must have a common portion, which is in fact a continuous three-dimensional locus of event particles in the four-dimensional manifold. A three-dimensional locus of event particles which is the common portion of the boundary of two adjoined events will be called a solid. A solid may or may not lie completely in one moment. A solid which does not lie in one moment will be called a vagrant. A solid which does lie in one moment will be called a volume. A volume may be defined as the locus of the event particles in which a moment intersects an event, provided that the two do intersect. The intersection of a moment and an event will evidently consist of those event particles which are covered by the moment and lie in the event. The identity of the two definitions of a volume is evident when we remember that an intersecting moment divides the event into two adjoined events. A solid as thus defined, whether it be vagrant or be a volume, is a mere aggregate of event particles illustrating a certain quality of position. We can also define a solid as an abstractive element. In order to do so we recur to the theory of primes explained in the preceding lecture. Let the condition named sigma stand for the fact that each of the events of any abstractive set satisfying it has all the event particles of some particular solid lying in it. Then the group of all the sigma primes is the abstractive element which is associated with the given solid. I will call this abstractive element the solid as an abstractive element, and I will call the aggregate of event particles the solid as a locus. The instantaneous volumes in instantaneous space, which are the ideals of our sense perception, are volumes as abstractive elements. What we really perceive with all our efforts after exactness are small events far enough down some abstractive set belonging to the volume as an abstractive element. It is difficult to know how far we approximate to any perception of vagrant solids. We certainly do not think that we make any such approximation. But then our thoughts, in the case of people who do think about such topics, are so much under the control of the materialistic theory of nature that they hardly count for evidence. If Einstein's theory of gravitation has any truth in it, vagrant solids are of great importance in science. The whole boundary of a finite event may be looked on as a particular example of a vagrant solid as a locus. Its particular property of being closed prevents it from being definable as an abstractive element. When a moment intersects an event, it also intersects the boundary of that event. This locus, which is the portion of the boundary contained in the moment, is the bounding surface of the corresponding volume of that event contained in the moment. It is a two-dimensional locus. The fact that every volume has a bounding surface is the origin of the Dedekindian continuity of space. Another event may be cut by the same moment in another volume, and this volume will also have its boundary. These two volumes in the instantaneous space of one moment may mutually overlap in the familiar way which I need not describe in detail, and thus cut off portions from each other's surfaces. These portions of surfaces are momental areas. It is unnecessary at this stage to enter into the complexity of a definition of vagrant areas. Their definition is simple enough when the four-dimensional manifold of event particles has been more fully explored as to its properties. Momental areas can evidently be defined as abstractive elements by exactly the same method as applied to solids. We have merely to substitute area for a solid in the words of the definition already given. Also, exactly as in the analogous case of a solid, what we perceive as an approximation to our ideal of an area is a small event far enough down towards the small end of one of the equal abstractive sets which belongs to the area as an abstractive element. Two momental areas lying in the same moment can cut each other in a momental segment which is not necessarily rectilinear. Such a segment can also be defined as an abstractive element. It is then called a momental route. We will not delay over any general consideration of these momental routes, nor is it important for us to proceed to the still wider investigation of vagrant routes in general. There are, however, two simple sets of routes which are of vital importance. One is a set of momental routes, and the other of vagrant routes. Both sets can be classed together as straight routes. We proceed to define them without any reference to the definitions of volumes and surfaces. The two types of straight routes will be called rectilinear routes and stations. Rectilinear routes are momental routes, and stations are vagrant routes. Rectilinear routes are routes which in a sense lie in rects. Any two event particles on a rect define the set of event particles which lie between them on that rect. Let the satisfaction of the condition sigma by an abstractive set mean that the two given event particles and the event particles lying between them on the rect all lie in every event belonging to the abstractive set. The group of sigma primes, where sigma has this meaning, form an abstractive element. Such abstractive elements are rectilinear routes. They are the segments of instantaneous straight lines which are the ideals of exact perception. Our actual perception, however exact, will be the perception of a small event sufficiently far down one of the abstractive sets of the abstractive element. A station is a vagrant route, and no moment can intersect any station in more than one event particle. Thus a station carries with it a comparison of the positions in their respective moments of the event particles covered by it. Rects arise from the intersection of moments, but as yet no properties of events have been mentioned by which any analogous vagrant loci can be found out. The general problem for our investigation is to determine a method of comparison of position in one instantaneous space with positions in other instantaneous spaces. We may limit ourselves to the spaces of the parallel moments of one time system. How are positions in these various spaces to be compared? In other words, what do we mean by motion? It is the fundamental question to be asked of any theory of relative space, and like many other fundamental questions it is apt to be left unanswered. It is not an answer to reply that we all know what we mean by motion. Of course we do, so far as sense-awareness is concerned. I am asking that your theory of space should provide nature with something to be observed. You have not settled the question by bringing forward a theory according to which there is nothing to be observed, and by then reiterating that nevertheless we do observe this non-existent fact. Unless motion is something as a fact in nature, kinetic energy and momentum, and all that depends on these physical concepts, evaporate from our list of physical realities. Even in this revolutionary age, my conservationism resolutely opposes the identification of momentum and moonshine. Accordingly, I assume it as an axiom that motion is a physical fact. It is something that we perceive as in nature. Motion presupposes rest, until theory arose to vitiate immediate intuition. That is to say, to vitiate the uncriticized judgments which immediately arise from sense-awareness. No one doubted that in motion you leave behind that which is at rest. Abraham in his wanderings left his birthplace where it had ever been. A theory of motion and a theory of rest are the same thing viewed from different aspects with altered emphasis. You cannot have a theory of rest without in some sense admitting a theory of absolute position. It is usually assumed that relative space implies that there is no absolute position. That is, according to my creed, a mistake. The assumption arises from the failure to make another distinction, namely, that there may be alternative definitions of absolute position. This possibility enters with the admission of alternative time systems. Thus the series of spaces in the parallel moments of one temporal series may have their own definition of absolute position, correlating sets of event particles in these successive spaces, so that each set consists of event particles, one from each space, all with the property of possessing the same absolute position in that series of spaces. Such a set of event particles will form a point in the timeless space of that time system. Thus a point is really an absolute position in the timeless space of a given time system. But there are alternative time systems, and each time system has its own peculiar group of points, that is to say, its own peculiar definition of absolute position. This is exactly the theory which I will elaborate. In looking to nature for evidence of absolute position, it is of no use to recur to the four-dimensional manifold of event particles. This manifold has been obtained by the extension of thought beyond the immediacy of observation. We shall find nothing in it except what we have put there to represent the ideas in thought which arise from our direct sense-awareness of nature. To find evidence of the properties which are to be found in the manifold of event particles, we must always recur to the observation of relations between events. Our problem is to determine those relations between events which issue in the property of absolute position in a timeless space. This is, in fact, the problem of the determination of the very meaning of the timeless spaces of physical science. In reviewing the factors of nature as immediately disclosed in sense-awareness, we should note the fundamental character of the precept of being here. We discern an event merely as a factor in a determinate complex in which each factor has its own peculiar share. There are two factors which are always ingredient in this complex. One is the duration which is represented in thought by the concept of all nature that is present now, and the other is the peculiar locus standi for mind involved in the sense-awareness. This locus standi in nature is what is represented in thought by the concept of here, namely of an event here. This is the concept of a definite factor in nature. This factor is an event in nature which is the focus in nature for that act of awareness, and the other events are perceived as referred to it. This event is part of the associated duration. I call it the percipient event. This event is not the mind, that is to say, not the percipient. It is in that nature from which the mind perceives. The complete foothold of the mind in nature is represented by the pair of events, namely, the present duration which marks the when of awareness, and the percipient event which marks the where of awareness and the how of awareness. This percipient event is, roughly speaking, the bodily life of the incarnate mind. But this identification is only a rough one, for the functions of the body shade off into those of other events in nature, so that for some purposes the percipient event is to be reckoned as merely part of the bodily life, and for other purposes it may even be reckoned as more than the bodily life. In many respects the demarcation is purely arbitrary, depending on where in a sliding scale you choose to draw the line. I have already in my previous lecture on time discussed the association of mind with nature. The difficulty of the discussion lies in the liability of constant factors to be overlooked. We never note them by contrast with their absences. The purpose of a discussion of such factors may be described as being to make obvious things look odd. We cannot envision them unless we manage to invest them with some of the freshness which is due to strangeness. It is because of this habit of letting constant factors slip from consciousness that we constantly fall into the error of thinking of the sense awareness of a particular factor in nature as being a two-termed relation between the mind and the factor. For example, I perceive a green leaf. Language in this statement suppresses all reference to any factors other than the percipient mind and the green leaf and the relation of the sense awareness. It discards the obvious inevitable factors which are essential elements in the perception. I am here, the leaf is there, and the event here and the event which is the life of the leaf there are both embedded in a totality of nature which is now, and within this totality there are other discriminated factors which it is irrelevant to mention. Thus language habitually sets before the mind a misleading abstract of the indefinite complexity of the fact of sense awareness. What I now want to discuss is the special relation of the percipient event which is here to the duration which is now. This relation is a fact in nature, namely the mind is aware of nature as being with these two factors in this relation. Within the short present duration of the here of the percipient event has a definite meaning of some sort. This meaning of here is the content of the special relation of the percipient event to its associated duration. I will call this relation cogredience. Accordingly, I ask for a description of the character of the relation of cogredience. The present snaps into a past and a present when the here of cogredience loses its single determinate meaning. There has been a passage of nature from the here of perception within the past duration to the different here of perception within the present duration, but the two heres of sense awareness within neighbouring durations may be indistinguishable. In this case there has been a passage from the past to the present, but a more retentive perceptive force might have retained the passing nature as one complete present instead of letting the earlier duration slip into the past. Namely, the sense of rest helps the integration of durations into a prolonged present, and the sense of motion differentiates nature into a succession of shortened durations. As we look out of a railway carriage in an express train, the present is past before reflection can seize it. We live in snippets too quick for thought. On the other hand, the immediate present is prolonged according as nature presents itself to us in an aspect of unbroken rest. Any change in nature provides ground for a differentiation among durations so as to shorten the present. But there is a great distinction between self-change in nature and change in external nature. Self-change in nature is change in the quality of the standpoint of the percipient event. It is the break-up of the here which necessitates the break-up of the present duration. Change in external nature is compatible with a prolongation of the present of contemplation rooted in a given standpoint. What I want to bring out is that the preservation of a peculiar relation to a duration is a necessary condition for the function of that duration as a present duration for self-awareness. This peculiar relation is the relation of cogredience between the percipient event and the duration. Cogredience is the preservation of unbroken quality of standpoint within the duration. It is the continuance of identity of station within the whole of nature which is the terminus of sense-awareness. The duration may comprise change within itself, but cannot, so far as it is one present duration, comprise change in the quality of its peculiar relation to the contained percipient event. In other words, perception is always here, and a duration can only be posited as present for sense-awareness on condition that it affords one unbroken meaning of here in its relation to the percipient event. It is only in the past that you can have been there with a standpoint distinct from your present here. Events there and events here are facts of nature. and the qualities of being there and here are not merely qualities of awareness as a relation between nature and mind. The quality of determinate station in the duration which belongs to an event which is here, in one determinate sense of here, is the same kind of quality of station which belongs to an event which is there, in one determinate sense of there. Thus cogredience has nothing to do with any biological character of the event which is related by it to the associated duration. This biological character is apparently a further condition for the peculiar connection of a percipient event with the percipience of mind, but it has nothing to do with the relation of the percipient event to the duration which is the present whole of nature posited as the disclosure of the percipience. Given the requisite biological character, the event in its character of a percipient event selects that duration with which the operative past of the event is practically cogredient within the limits of the exactitude of observation, namely, amid the alternative time systems which nature offers there will be one with a duration giving the best average of cogredience for all the subordinate parts of the percipient event. This duration will be the whole of nature, which is the terminus posited by sense awareness. Thus the character of the percipient event determines the time system immediately evident in nature. As the character of the percipient event changes with the passage of nature, or, in other words, as the percipient mind in its passage correlates itself with the passage of the percipient event into another percipient event, the time system correlated with the percipience of that mind may change. When the bulk of the events perceived are cogredient in a duration other than that of the percipient event, the percipience may include a double consciousness of cogredience, namely the consciousness of the whole within the observer in the train is here, and the consciousness of the whole within which the trees and bridges and telegraph posts are definitely there. Thus in perceptions under certain circumstances the events discriminated assert their own relations of cogredience. This assertion of cogredience is peculiarly evident when the duration to which the perceived event is cogredient is the same as the duration which is the present whole of nature. In other words, when the event and the percipient event are both cogredient to the same duration. We are now prepared to consider the meaning of stations in a duration, where stations are a peculiar kind of routes, which define absolute position in the associated timeless space. There are, however, some preliminary explanations. A finite event will be said to extend throughout a duration when it is part of the duration, and is intersected by any moment which lies in the duration. Such an event begins with the duration and ends with it. Furthermore, every event which begins with the duration and ends with it extends throughout the duration. This is an axiom based on the continuity of events. By beginning with a duration and ending with it, I mean 1. That the event is part of the duration, and 2. That both the initial and final boundary moments of the duration cover some event particles on the boundary of the event. Every event which is cogredient with the duration extends throughout that duration. It is not true that all the parts of an event cogredient with the duration are also cogredient with the duration. The relation of cogredience may fail in either of two ways. One reason for failure may be that the part does not extend throughout the duration. In this case the part may be cogredient with another duration which is part of the given duration, though it is not congredient with the given duration itself. Such a part would be cogredient if its existence were sufficiently prolonged in that time system. The other reason for failure arises from the four-dimensional extension of events so that there is no determinate route of transition of events in linear series. For example, the tunnel of a tube railway is an event at rest in a certain time system, that is to say, it is cogredient with a certain duration. A train travelling in it is part of that tunnel, but is not itself at rest. If an event E be cogredient with a duration d, and d' be any duration which is part of d, then d' belongs to the same time system as d. Also d' intersects E in an event E' which is part of E and is cogredient with d'. Let P be any event particle lying in a given duration d. Consider the aggregate of events in which P lies, and which are also cogredient with d. Each of these events occupies its own aggregate of event particles. These aggregates will have a common portion, namely the class of event particle lying in all of them. This class of event particles is what I call the station of the event particle P in the duration d. This is the station in the character of a locus. A station can also be defined in the character of an abstractive element. Let the property σ be the name of the property which an abstractive set possesses when 1. Each of its events is cogredient with the duration d, and 2. The event particle P lies in each of its events. Then the group of σ primes, where σ has this meaning, is an abstractive element, and is the station of P in d as an abstractive element. The locus of event particles covered by the station of P in d as an abstractive element is the station of P in d as a locus. A station has accordingly the usual three characters, namely its character of position, its extrinsic character as an abstractive element, and its intrinsic character. It follows from the peculiar properties of rest that two stations belonging to the same duration cannot intersect. Accordingly, every event particle on a station of duration has that station as its station in the duration. Also every duration which is part of a given duration intersects the stations of the given duration in loci which are its own stations. By means of these properties we can utilize the overlappings of the duration of one family, that is, of one time system, to prolong stations indefinitely backwards and forwards. Such a prolonged station will be called a point track. A point track is a locus of event particles. It is defined by reference to one particular time system, alpha say. Corresponding to any other time systems, these will be a different group of point tracks. Every event particle will lie on one and only one point track of the group belonging to any one time system. The group of point tracks of the time system alpha is the group of points of the timeless space of alpha. Each such point indicates a certain quality of absolute position in reference to the durations of the family associated with alpha, and thence in reference to the successive instantaneous spaces lying in the successive moments of alpha. Each moment of alpha will intersect a point track in one and only one event particle. This property of the unique intersection of a moment and a point track is not confined to the case when the moment and the point track belong to the same time system. Any two event particles on a point track are sequential, so that they cannot lie in the same moment. Accordingly, no moment can intersect a point track more than once, and every moment intersects a point track in one event particle. Anyone who at the successive moments of alpha should be at the event particles where those moments intersect a given point of alpha will be at rest in the timeless space of time system alpha. But in any other timeless space belonging to another time system he will be at a different point at each succeeding moment of that time system. In other words, he will be moving. He will be moving in a straight line with uniform velocity. He might take this as the definition of a straight line, namely, a straight line in the space of time system beta is the locus of those points of beta, which all intersect some one point track which is a point in the space of some other time system. Thus, each point in the space of a time system alpha is associated with one and only one straight line of the space of any other time system beta. Furthermore, the set of straight lines in space beta, which are thus associated with points in space alpha, form a complete family of parallel straight lines in space beta. Thus there is a one-to-one correlation of points in space alpha with the straight lines of a certain definite family of parallel straight lines in space beta. Conversely, there is an analogous one-to-one correlation of the points in space beta with the straight lines of a certain family of parallel straight lines in space alpha. These families will be called respectively the family of parallels in beta associated with alpha and the family of parallels in alpha associated with beta. The direction in space of beta, indicated by the family of parallels in beta, will be called the direction of alpha in space beta, and the family of parallels in alpha is the direction of beta in space alpha. Thus a being at rest at a point of space alpha will be moving uniformly along a line in space beta, which is in the direction of alpha in space beta, and a being at rest at a point of space beta will be moving uniformly along a line in space alpha, which is in the direction of beta in space alpha. I have been speaking of the timeless spaces which are associated with time systems. These are the spaces of physical science and of any concept of space as eternal and unchanging. But what we actually perceive is an approximation to the instantaneous space indicated by event particles which lie within some moment of the time system associated with our awareness. The points of such an instantaneous space are event particles and the straight lines are rects. Let the time system be named alpha, and let the moment of time system alpha, to which our quick perception of nature approximates, be called m. Any straight line r in space alpha is a locus of points, and each point is a point track, which is a locus of event particles. Thus, in the four-dimensional geometry of all event particles, there is a two-dimensional locus, which is the locus of all event particles on points lying on the straight line r. I will call this locus of event particles the matrix of the straight line r. A matrix intersects any moment in a rect. Thus, the matrix of r intersects the moment m in a rect ρ. Thus, ρ is the instantaneous rect in m which occupies at the moment m the straight line r in the space of alpha. Accordingly, when one sees instantaneously a moving being and its path ahead of it, what one really sees is the being at some event particle lying in the rect ρ, which is the apparent path on the assumption of uniform motion. But the actual rect ρ, which is a locus of event particles, is never traversed by the being. These event particles are the instantaneous facts which pass with the instantaneous moment. What is really traversed are other event particles which at succeeding instants occupy the same points of space alpha as those occupied by the event particles of the rect ρ. For example, we see a stretch of road and a lorry moving along it. The instantaneously seen road is a portion of the rect ρ, of course, only an approximation to it. The lorry is the moving object, but the road as seen is never traversed. It is thought of as being traversed because the intrinsic characters of the latter events are in general so similar to those of the instantaneous road that we do not trouble to discriminate. But suppose a land mine under the road has been exploded before the lorry gets there. Then it is fairly obvious that the lorry does not traverse what we saw at first. Suppose the lorry is at rest in space beta. Then the straight line r of space alpha is in the direction of beta in space alpha, and the rect ρ is the representative in the moment m of the line r of space alpha. The direction of ρ in the instantaneous space of the moment m is the direction of β in m, where m is a moment of time system α. Again, the matrix of the line r of space α will also be the matrix of some line S of space β, which will be in the direction of α in space β. Thus, if the lorry halts at some point P of space α which lies on the line r, it is now moving along the line S of space β. This is the theory of relative motion. The common matrix is the bond which connects the motion of β in space α with the motions of α in space β. Motion is essentially a relation between some object of nature and the one timeless space of a time system. An instantaneous space is static, being related to the static nature at an instant. In perception, when we see things moving in an approximation to an instantaneous space, the future lines of motion as immediately perceived are rects, which are never traversed. These approximate rects are composed of small events, namely approximate roots and event particles, which are passed away before the moving objects reach them. Assuming that our forecasts of rectilinear motion are correct, these rects occupy the straight lines in timeless space which are traversed. Thus the rects are symbols in immediate sense-awareness of a future which can only be expressed in terms of timeless space. We are now in a position to explore the fundamental character of perpendicularity. Consider the two time systems α and β, each with its own timeless space and its own family of instantaneous moments, with their instantaneous spaces. Let m and n be respectively a moment of α and a moment of β. In m there is the direction of β, and in n there is the direction of α. But m and n, being moments of different time systems, intersect in a level. Call this level λ. Then λ is an instantaneous plane in the instantaneous space of m, and also in the instantaneous space of n. It is the locus of all the event particles which lie both in m and in n. In the instantaneous space of m the level λ is perpendicular to the direction of β in m, and in the instantaneous space of n the level λ is perpendicular to the direction of α in n. This is the fundamental property which forms the definition of perpendicularity. The symmetry of perpendicularity is a particular instance of the symmetry of the mutual relations between two time systems. We shall find in the next lecture that it is from this symmetry that the theory of congruence is deduced. The theory of perpendicularity in the timeless space of any time system α follows immediately from this theory of perpendicularity in each of its instantaneous spaces. Let ρ be any rect in the moment m of α, and let λ be a level in m which is perpendicular to ρ. The locus of those points in the space of α which intersects m in event particles on ρ is the straight line r of space α, and the locus of those points of space α which intersects m in event particles on λ is the plane 1 of space α. Then the plane 1 is perpendicular to the line r. In this way we have pointed out unique and definite properties in nature which correspond to perpendicularity. We shall find that this discovery of definite unique properties defining perpendicularity is of critical importance in the theory of congruence, which is the topic for the next lecture. I regret that it has been necessary for me in this lecture to administer such a large dose of four-dimensional geometry. I do not apologize, because I am really not responsible for the fact that nature, in its most fundamental aspect, is four-dimensional. Things are what they are, and it is useless to disguise the fact that what things are is often very difficult for our intellects to follow. It is a mere evasion of the ultimate problems to shirk such obstacles. End of chapter 5.